I've always been fascinated with spy movies, the covert operations and close calls. However, what intrigued me the most was what lay behind the scenes, the secret codes that would be sent between personnel that could only be deciphered by someone with the right key. So, naturally when I heard of the coding competition, I thought about making an encrypting and decrypting program. This led to the version 5 MATLAB encrypted messaging service, which uses a crude form of asymmetric key encryption. The creation involved two parts, the first to design and make the encryption script, and the second to implement that encryption script into a messaging program. The final product resulted in numerous types of functions. Starting at the beginning, the final version needed a way to check to see if a user was already registered. This involved a user creation script that would append a user list. To see if a user was registered, I used a while loop with string compare, which would return true if the inputted name of the user ever appeared in the user list. Similarly, it needed a password function so that other users couldn't delete others' messages. Using string compare again, we checked inputted information with the saved password from the user creation script. Both functions, as well as other functions, required the use of loading variable files. To accomplish this, we used the bracketed form of the load function and used sprintf to concatenate a constant file descriptor with the user's name. The main difference between versions 4 and 5 is that version 5 is an organized form of version 4. It involves sectioning most things into functions for improved readability. As I was doing this, I noticed an error in version 4. With version 5, I noticed that I never loaded the public key for the recipient and instead used the sender's key to encrypt, like locking a door with your key and asking your friend to open it with theirs. The lesson learned? Functions are priceless to understanding what path the computer takes in reading your code. The end product, after properly converting to functions, should look very similar to your pseudocode, essentially being effortless to follow. The encryption script made in part 1 and implemented into the final product uses prime numbers as keys because they are harder to factor for computers and thus make them safer as a key. This required a program to find prime numbers to be used in the encryption. The initial version took over 3 minutes to calculate the first 20,000 prime numbers. After some optimization, it could do the same in about 13 seconds, just because of understanding the problem at hand. Did you know that all non-primes have a factor that is a prime? Using this one property I learned from a friend, I could optimize my program. Even a non-programmer can help you understand a problem, and understanding a problem is paramount. You should always understand a problem before trying to code something that can solve it. A computer can do operations really fast, but they only do them based on how they are told to do so. A computer improperly programmed, improperly told how to solve a problem, will never reach the right solution. Always check for logical errors. The encryptor functions just like a Visionaire cipher. When encrypting, we are given the message and the cipher and must find the ciphertext. The ciphertext is just the intersection in a matrix from the message and cipher. In this example, hello is the message and lemon is the cipher. We do this across the whole message until we get the ciphertext. When decrypting, we are given the ciphertext and cipher, but we must find the plaintext. This is the harder part because we can't use string find to get the message. This required the use of a pen and paper and some Sudoku-like skills to figure out the pattern. Even if you are writing code, don't be shy to pull out an old-fashioned pen and paper to make sure that there aren't any logical errors in your script. So, if you are ever on a spy mission, know that the MATLAB encrypted messaging service will have your back if you have the right key, and remember, the pen may be mightier than the sword, but a computer can be mightier than the pen if the person who wrote the code knows what they are doing.